Hello students, welcome back. Let's take up another board question, and this is from the year 2024 and this question carries 2 marks. The question is, use Ohm's law to determine the potential difference across the 3 ohm resistor in the circuit as shown in the following diagram when the key is closed. So here we have been given a circuit diagram in which there are 3 resistors, 1 ohm, 3 ohm and 2 ohm, which are connected in this circuit, and the potential difference of this circuit is 2 volt, and when the key is pressed, some amount of current flows in this circuit. Now we have to find out the potential difference across this 3 ohm resistor. Now before we proceed, I'd like to highlight one mistake that students make here, that is finding out whether this is a series circuit or a parallel circuit. Now I have made a video on how to identify very easily whether the resistors are in series or parallel, and I've also solved the question. This method is known as the OTC method, that is opening the circuit method. If you have not seen these videos, I'll attach the link of those videos at the end of this video, which will help you to understand and solve the circuit diagram based questions very easily, as you will be able to identify whether the circuit is a series circuit or a parallel circuit. Now coming back to our question, let's open this circuit and see if the circuit is a series or a parallel circuit. So now what we will do is that we will start opening the circuit from this part, that is from the battery. Now let's take this small negative part. So I write here, so this is the negative terminal. Now one wire from the negative terminal of the battery goes and it's attached to the 1 ohm resistor. So from here I take one wire and this is my 1 ohm resistor. At the other end of this resistor, the wire simply bends over here. You can see here there is no other wire, only the wire is bending. If we pull apart this side and this side, they will open up. Now you see here, when this part is stretched, it will be one single wire only which is turning at 2 parts. There is no branching over here. So one wire only, if we stretch it, it becomes straight. And you see in that same line only we have the 3 ohm resistor and 2 ohm resistor connected. You see this wire comes here, you find the 3 ohm resistor. On the other side of the resistor, that same line continues and it's attached to one end of this 2 ohm resistor. So here is my 2 ohm resistor. So this is the 3 ohm resistor, this is the 2 ohm resistor. Now the other end, at the other end of the 2 ohm resistor, again the wire simply bends at this place, and again there is another one bending at this place. So simply it is the wire bending. So if you pull it apart, it will stretch and will be forming one single line. So this is the other end of this 2 ohm resistor. So this wire goes, it bends and again bends, and it is connected to the key. So this is my key over here. Now the other end of the key is connected to the positive terminal of the battery. So this is the other end of the key K, and this is connected to the positive terminal of the battery. So using this OTC method or opening the circuit method, we can easily identify whether the circuit is a series or a parallel one, or the resistors are connected in series or parallel. Now since there is no branch over here, all the resistors are connected in a single line. So this circuit is a series circuit. So now that we are clear with the series circuit, let's find out the potential difference across this 3 ohm resistor. So first let's find out what's the resistance of this circuit, and then we'll find out what is the current flowing in this circuit, and then finally apply Ohm's law to find out the potential difference across the 3 ohm resistor. We know that in a series circuit, potential difference varies across each resistor. So we have to find out the potential difference across this 3 ohm resistor. So first let's find out the equivalent resistance when these resistors are connected in series. Now we know when the resistors are connected in series, the equivalent resistance is given by R1 plus R2 plus R3. Now R1 over here is 1 ohm plus R2 is 3 ohm plus R3 is 2 ohm. So we get a total of 6 ohm. So the equivalent resistance of this entire circuit is 6 ohm. Now we have the resistance of the circuit. Now the potential difference is given as 2 volt. So potential difference is 2 volt. Hence, using Ohm's law, that is V is equal to IR. Now I will be V by R. Now the potential difference of the circuit is 2 volt and the equivalent resistance we found out is 6 ohm. So the value comes to be 1 by 3 ampere. So the current in the circuit is 1 by 3 ampere. Now this 1 by 3 ampere current will flow through this entire circuit. So in order to find out the potential difference across this 3 ohm resistor, we'll again have to apply Ohm's law. So let's write down. So the potential difference across the 3 ohm resistor is V is equal to I R. Current value we found out is 1 by 3 into the resistance value given over here is 3 ohm. So this 3 and 3 cancels. It is 1. Hence the potential difference across the 3 ohm resistor is 1 volt. So this is the answer to this question, that is the potential difference across the 3 ohm resistor is 1 volt. So if you are thorough with this opening the circuit method or the OTC method, you can open up any complicated circuit and you can easily find out the equivalent resistance when the resistors are connected in different combinations. Please do watch that video because it will help you to solve other circuit diagram based questions. So with that, we come to the end of this video. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.